This is lecture 19.2, and we're going to be looking at the concept of pH today. So what I'd like you to first do is to draw a pH scale. And you can get a ruler, or you can just do this by freehand if you want. And we're going to review the numbers on the pH scale, what it means to be an acid, what it means to be a base. So down on this end, we have a pH of 0. On the other end, we have a pH of 14. And right in the middle, we will have a pH of 7. So this is our pH scale. Again, down between 0 and 7, this is going to be our range of things that are acid. Above pH of 7, this is when we're going to have a base. And of course, 7 is right in the middle. When we talked about being right in the middle, it doesn't mean that you lack acid or that you lack base. It means that you have an equal concentration of both acids and bases. So this is going to be neutral. And when you're neutral, your hydrogen concentration is going to be equal to your hydroxide concentration or your OH concentration. So let's take a look at the numerical values of what it means to be neutral. If you're neutral and at a pH of 7, what you have is you have a concentration is going to be 1.0 times 10 to the minus 7 molar, and the concentration of this is going to be H+. So if the OH concentration when it's neutral is equal to the hydrogen concentration, that means we're also going to have a 1.0 times 10 to the minus 7 molar of OH minus. What that means is that the number of moles of hydroxide ions is going to equal the number of moles of your hydrogen ions. These are going to be equal. The number of molecules is going to be equal, and therefore it's going to be neutral. It's not going to be acidic, and it's not going to be basic. What's very interesting to start to note here is notice that we have the 7, and we have a pH of 7, and it's 10 to the minus 7 molar for each of those. We'll get back to the numbers in a little bit. I'm going to give you the concentrations of being an acid. Well, remember, an acid's going to have more H+ than when it's neutral. And the concentration of the H+ is going to be, at a pH of 0, 1.0 times 10 to the 0. Notice that it has a 0 for the pH as well. And the concentration is molar of H+. So this looks like it's less because we have a 0 and a negative 7. But in reality, this is 0.000001 molar of H+. This is 1 times 10 to the 0. Anything to the 0 power is actually 1. This is a 1 molar H+ concentration will be a pH of 0. So this is a million times stronger than a neutral concentration. So 10 to the 0 is larger than 10 to the minus 7. Negative exponents are a little bit tricky. So the concentration with an acid, again, here the concentrations are going to be equal. When you have an acid, the H+ concentration, if you remember, is going to be greater than the OH minus concentration. To be acid means we have more acid. Well, what is the concentration going to be for the base? It is 1.0 times 10 to the minus 14 molar OH minus. So this is a million times more of the H+ concentration compared to the OH minus concentration. This far exceeds this amount right here. which is showing that it's going to be an acid. Let's go to the other end of the pH scale, and we're looking at the base. Concentration of the base, of the acid. Well, let's take a look. We're going to be having a OH minus is going to be greater than the H plus here. So that's what we're looking for. So that means the hydrogen ion concentration must be less than what it was right here. The actual concentration is 1.0 times 10 to the minus 14 molar of H plus. So we have a million, this is 10 to the minus 7, this is 10 to the minus 14. This is a million, or even more so, maybe 10 million, times less acid than it had when it was neutral. This is going to be 1.0 times 10 to the 0 molar of OH minus. So some things to note are the 0 for the H plus concentration. We have the 7 and the 7 for the H plus concentration, and we have the 14 and the 14 for the H plus concentration. That's how concentration is determined. I'm going to give you an equation which you will not have to use, but I want to give it to you anyway so you can see how this works. And we're going to go over the tricks to solving for these things without using the calculator. Here's the definition though of pH. The pH is going to be equal to the negative log of the hydrogen ion concentration. So for example, let's go to my neutral. Let's say I have 1.0 times 10 to the minus 7. If I take the log of my answer, take the log of my concentration, notice I get negative 7, but if I multiply that by a negative 1, because it's a negative, I have a pH of 7. If I have a 1 times 10 to the 0, which will give me 1, if I take the log of 1, it will give me 0. My pH is 0. Going over here, if I take the hydrogen ion concentration, 1.0 times 10 to the minus 14, if I take the log of that value and then multiply it by, again, a negative 1, I will get a pH of 14. So that's the definition of pH and how to calculate it with the calculator. Let's go over how to do this without the calculator, and hopefully you'll be able to see this by repetition and by pattern. So let's say you have a pH of 3. So the pH is 3. This is going to be equal to, well, what's the molarity of this going to be? If my pH of 0 is 1 times 10 to the 0 molar, and my pH of 7 is 1 times 10 to the minus 7, what is the pH of 3 going to be equal to? It's going to be equal to 1.0 times 10 to the minus 3 molar of the of the H plus concentration. So your pH is going to be equal to that exponent right there. Now, this only works when you are dealing with the whole numbers. It doesn't work when you have like a pH of 4.2. Okay, it doesn't work that way on the logarithmic scale. But when we're using whole numbers, which we will for the purposes of this, for the purposes of your homework, and for the purpose of the exam. So what does this actually mean in terms of a decimal? This means that it's going to be 0.001 molar of H plus. And again, I can plug that in my calculator, 0.001, okay, and I can take the log of that answer and then multiply it by -1, and that would tell me it's a pH of 3. I can work backwards to get to that response right there. Well, what is the OH minus concentration going to be? Notice something that's really interesting is that when we're neutral, we have 7 and 7. When it's acid, we have 0 and 14. When we have a base, we have 14 and 0. All three of these add to 14. So my OH minus concentration will be 1.0 times 10 to the minus, what's going to add to 14 here? 11 molar. Now again, pH 3 is here, it means it's very, very acidic. 10 to the minus 3 is much larger than 10 to the minus 11, because remember, we're dealing with negative exponents. This is 0.001. This is 0.0000000000001. Okay, so this is much smaller than this, so that way it's going to be acidic. Let's take a look at a pH of 9. Okay, what's this going to be in terms of the H plus concentration? Follow the pattern. 1.0 times 10 to the minus 9 molar H plus concentration. What's the OH minus concentration going to be? Remember, your exponents have to add to 14, or negative 14. So this is going to be 1.0 times 10 to the minus 5 molar. Let's work backwards and see what's the pH going to be. If I have 1.0 times 10 to the minus 5 molar of hydrogen ions, this is going to be equal to a pH of what? Well, if 3 is -3 and 9 is -9, -5 is going to be pH of 5. What will 1.0 times 10 to the minus 11 molar H plus be? This will equal a pH of 11. So now let's get in some tricky ones. Okay, let's try 1.0 times 10 to the minus 10 molar of OH minus. Well, this, remember, this pH scale works with the log of the H, but notice how I don't have my H plus concentration. I first need to figure out what my H plus concentration is. Well, remember that your exponents are going to be adding up to 14. So if this is my concentration of base, what's the concentration of my acid going to be? 1.0 times 10 to the minus, remember your exponents have to add to 14, so this is going to be 4 molar of H plus. And now that we have the H plus, we can calculate the pH. In this case, the pH is going to be equal to 4. Okay, what if you have 1.0, following this example, times 10 to the minus 2 molar of OH minus? What pH will you have there? You first have to calculate the H plus concentration. 1.0 times 10 to the, what's going to add to 2 to make 14? Negative 12 molar of H plus. So my pH in this case is going to be equal to 12. This is going from pH to the hydrogen and hydroxide concentrations, going from the hydrogen ion concentration to the pH, and also the hydroxide ion to the pH. But what happens if you're given a decimal? So we're going to take a look at a couple of these. What if you have 0.000, and I'm going to write these with spaces so you can actually see them very easily, 0.001 molar of H plus. Okay, well, this is going to be equal to 1.0 times 10 to the how many decimal places do I have to move it over? 1, 2, 3, 4, 5, 6, 7. So I have 1 times 10 to the minus 7 molar of H plus. That means this is going to be a pH of, now that it's in the H plus concentration, it's going to be a pH of 7. What if I have a concentration of 0.00000000001 molar of OH minus? What is this in scientific notation? 1, 2, 3. (1.0) times 10 to the minus 10 molar OH minus concentration. Now remember, this is OH. This is not going to be a pH of 10 because this is the OH concentration. We need this to be an H plus concentration. What's the H plus concentration going to be? Remember, your exponents have to add to 14. And now that we're in the hydrogen ion concentration, this is going to be a pH of 4. So again, this works with whole numbers, and with numbers that are with the 1.0. However, what if you had a concentration of this? This is the work you will not need to show, but I want to show you that you can actually calculate what the pH is on your calculator. What if you had 0.000003 molar H plus concentration? Okay, now this is very close to this number right here, but it's actually more. So is this pH, if we have more H plus, is that going to be more acid or more base? Well, let's see. All I have to do is take the log of 0.000003 and multiply by a -1, and it will tell me that it's going to be a pH of about 6.5. Comparing these two, this has more acid, more H plus, it's more acidic, so therefore it's going to be going down on the pH scale. However, it's not a pH of 6 because it would have to be a 1 right here to be a pH of 6.